Hello, grade nines, and welcome to what we are busy with at the moment, and that is solving simple exponential equations. And we are basically going to rely on your grade 8 prior knowledge on how to solve x with an equation. So it's basic, it's simple ones, but it has the exponential. So I just want to walk you through all the types of questions that you can get and also the steps you will be following to solve for x. All right, so the main aim is that we want to get the two bases to be the same. So that two and that we want to be the same. And we're going to use the product of our primes. If you remember in grade 7 or in grade 8, we started learning about how to every number is made up out of a product of its primes. Okay, is made up out of a combination, a multiplication of different prime numbers. So if you think of the prime numbers that you get 2, you get 3, you get 5, you get 7, you get 11, and it carries on and on. A prime number is a number that is only divisible by itself and the number 1. All right, so every number that you can think of is made up out of a combination, a product of prime numbers, a product meaning multiplication. So if we take 8 for instance, we know that 8 is made up out of 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So that will give you 2 to the power of 3. All right. But there's a simple way of just plotting it into your calculator if you don't have that knowledge down, and you want to find what the product, especially bigger numbers that you can't always foresee what the products would be. And in your calculator, you're going to press 8, then the equal button, then you're going to press shift, and then you're going to see there's a dot, comma, comma, comma button like that. And on top of it says fact. So we press shift to get to the second function over there, and you will see that the dot, comma, comma button is the factorization or the product of its primes. You press equal, not the factorization of it, sorry, and we're doing factorization in grade 10. At the moment, and that's why it's in my head, but we want to know the factors of what 8 is made up out of. And then it will tell you that 8 is made up out of 2 to the power of 3. Okay, so I know that you can say, oh, but then 2 to the power 3 will give you 8, so meaning 2 to the power 3 will give you 8, so x is 3. But I want you to understand the logic of how we get to, especially how to get to making it the product of its primes, because later on you won't be able just to guess the answers. Okay, so then we've got 2 to the power x is equal to 2 to the power 3, and then I always say, you can drop it like it's hot, because it's an equation, the bases drop, thus you're left with x is equal to 3. So the exponents are equal then to each other. Okay, so let's have a look at this one. So step 1, we want to make each side a product of its primes. So 2 to the power 4x is equal to 2 to the power of 4. So if you didn't know, you press 16 equals shift and then the dot, comma, comma, comma button, and then it will give you, that 16 is 2 to the power 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. Then we can drop it like it's hot, and we can equal the exponents to each other. 4x is equal to 4. So you can just ask yourself, 4 times what will give you 4? If you want to do the inverse operation, you will divide by 4 here to get x alone. And what you do on the one side, you have to do on the other side. Thus, x is equal to 1. Right, not too bad. Okay, over here, 5 is already a prime number. That's why I'm not changing him. But 125 can change into a product of its primes, which is 5 to the power of 3. Once we have that, we drop it like it's hot. And then we say 2x plus 1 is equal to 3. Take that loose term over, the plus 1 becomes a minus 1. So 2x is equal to 3 minus 1, which is 2. Thus, x is equal to 1. Hope that makes sense. All right, getting to the more harder ones, things that you just need to take note of. Please remember that the number 1 can always be written as a base of another number. So we can always write 1 as 3 to the power of 0, because anything to the power 0 is 1, except for 0 to the power 0. Hey, so we make it the same base as the other one. So always remember this little sneaky 1. That can always be changed into the same base as the other one, as long as I put it to the power of 0. Thus, we've got 3 to the power x minus 2 is equal to 3 to the power 0. We drop it like it's hot, and then we've got thus, or therefore, x minus 2 is equal to 0. Thus, x is equal to, if you throw that side over, it will become a positive 2. All right, for the next part, we always want to have one term is equal to one term. Although I know this is one term, we don't want anything attached to the base and the exponent. We don't want this coefficient here. And there's an easy way of just getting it away, dividing with that. But what you do on the one side, you have to do on the other side. Then you are left with 5 to the power x is equal to 30 divided by 6 is 5. So then again, we've got the same basis. Drop it like it's hot. And please remember the 5, if there's nothing, there's a 1 as an exponent. Thus, x is equal to 1. Okay, and you can always go test yourself. 5 to the power 1 is 5. 5 times 6 does give you 30. Okay, now these negatives that I know all of you love so much. Okay, 7 to the power x. I'm just going to do baby steps. I'm going to look at which one isn't a product of its primes. 7 is a prime number. 49 isn't. So I'm going to make 49 as 7 to the power of 2. Can you see they're not on the same level? This one we need to take upstairs so that we get rid of a fraction format so that we've got a base and a base. So if I do that, remember if an exponent changes its position, the exponent goes from a positive to a negative or negative to positive. So if it goes to the top, it will become 7 to the power negative 2. You can have it over 1, but because it's over 1, we can drop that away. Okay, now that we've got the same base, we drop it like it's hot. Thus, x is equal to negative 2. All right, getting the hang of it. Okay, other things to note, 1 to the power x. So I'm going to write it. So I'm going to simplify this. Everything inside the bracket is to the power 1. Sorry, mustn't do an equal sign. So it's 1 to the power x over 5 to the power x is equal to 125. I'm still going to write as a product of its primes, 5 to the power of 3. But now, if you look closely here, 1 to the power anything, 1 to the power 5 is 1. 1 to the power 10 is 1. So can you see that we can, in actual fact, not write that x? Because 1 to the power anything will always stay 1. Okay, and now can you see the upstairs, downstairs doesn't match here? We're going to take this upstairs, and then it's going to become a negative x. And now they're on the same level. And you can write it over 1, but you can also just leave that so that we have one level. Thus, negative x is equal to 3. And if you divide with a negative, because we don't want to find what's the value of negative x, we want to find the value of x. And if you divide with a negative on both sides, you get x is negative 3. All right, so now we've got on both sides that they are not product of their primes. So the 8 you can write or rewrite as 2 to the power of 3. And we're going to keep that in brackets because there's a power raised further to a power x. So it's 2 to the power 3 raised further to the power of x. So can you see all I did is I changed the 8 into a 2 to the power of 3. Then the x, if I had to rewrite that in black, is still sitting over there, is equal to the 4 I'm going to change in 2 to the power of 2, all raised still to x plus 3. Now, we're going to follow our golden rule. A power raised to a further power, you multiply. So it's going to be 2 to the power 3 times x, which is 3x. And over here, now you're going to say, oh, but now does the 2 go to the x? Does it go to the 3? Or does it go to both? Okay, you guessed it. It goes to both. So it's going to be 2 to the power 2x plus 2 times 3 is 6. Okay, so it doesn't just go to the first term. The 2 gets multiplied with the x and the 3. And now we can say we're going to drop it like it's hot. And we're going to equal the exponents to each other. And if you throw the x's, bring all the like terms together, it's going to become a minus x. 3x minus 2x is x is equal to 6. Okay, and then you can always go back and put your answer in the top there and see whether it makes sense. Does 8 to the power 6 equal to 4 to the power 6 plus 3, which is 9? You can go put that in your calculator and just go test it as well. All right, so let's just quickly run through a little bit more examples before we end off, just to get you used to all the types of examples that you can get and what to expect with this chapter. All right, so if we look here, which one isn't a product of its primes? The 81. If you put in 81 equals shift and the fact button, you will get that it's 3 to the power of 4. Then we're going to drop it like it's hot, and we equal the top parts, the exponents to each other. Divide with the negative on both sides, and you'll get x is negative 4. Okay, and if you take that, 3 to the power negative 4 should give you 3 to the power of negative, and negative makes a positive 4, which gives you 81. All right, the next example, all they want us to do is just to carry it over so that we've got 9 to the power x is equal to a positive 81. We're going to make each side, a product of its primes. So it's going to be 3 to the power of 2. If you replace the 9 as 3 to the power 2, and it's all raised to the power x, is equal to 3 to the power of 4. Remember, power raised to a further power, you multiply together. Then once we've got the same basis, we drop it like it's hot, and we've got 2x is equal to 4. Divide by 2 on each side, and x is equal to 2. All right, sometimes you don't have to make it a product of its primes, especially here. If you think of 10, it's made up out of 5 times 2. But now we're going to keep it as 10 because 100 is easily rewritten as 10 to the power of 2. So as long as the bases are the same, then we've got negative 2x is equal to 2. Divide with negative 2 on each side. Thus, x is negative 1. Okay, again, this one where we have to write, remember the 1. So 5 to the power x minus 1 is equal to, you can rewrite it as 5 to the power of 0. We've got the same basis. Drop it like it's hot. Thus, x minus 1 is 0. Thus, x is equal to 1. Does it make sense? 5 to the power 1 minus 1 is 0. 5 to the power 0 is 1. Okay, so you can always go and test yourself. All right, so 8 we're going to write as 2 to the power of 3, all raised to the power 2x minus 4 is equal to 1 over 2 to the power of 6. Want to keep it on the same level as the other, so we're going to take it to the top, and here we're going to distribute that 3 to multiply with the whole exponent over there. So then we get 2 to the power 3 times 2 is 6x minus 3 times 4 is 12 is equal to 2 to the power negative 6. Now they're all on the same level. We drop it like it's hot, and then we can equal the exponents to each other. If you bring that over, negative 6 plus 12 is equal to a positive 6. Thus, x is equal to 1. You can always go test it. 2 times 1 is 2. 2 minus 4 is negative 2. And if you put that in your calculator, 8 to the power negative 2 will give you 1 over 64. Okay, so you can always, if you've got time in a test, always go replace it in and see whether you can get the same answer. Okay, then product of its primes. So 1 to the power x, remember 1 to the power anything stays 1. And 4 is going to become 2 to the power of 2. And 16 is 2 to the power of 4. How do I change this so it's on the same level? I'm going to take it upstairs. But if I take it upstairs, sorry, I mustn't write an equal sign. If I take it upstairs, it's going to be 2 to the power negative 2 is equal to 2 to the power. No, man, sorry. I'm going to restart this sum. I made an oopsie doopsie. Okay, sorry, is equal to 4 raised to the power x is 4 to the power x. Okay, we can write the 4 in terms of its prime numbers. So it will be 2 to the power 2, all raised to the power of x. Sorry, so 4 is going to become 2 to the power 2, and that's also raised to the power x. Why did I drop that x over there? Because 1 to the power of anything gives you 1. Okay, so that's why we don't have to write that. And that gives you 2 to the power, 16 is 2 to the power of 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. And again, I mustn't write this equal, sorry. Okay, thus, hopefully I get this right now. 2 to the power 2 times x is 2 to the power 2x is equal to 2 to the power 4. Then I'm going to bring it upstairs so that it's on the same level. And then the exponent becomes a negative exponent. Drop it like it's hot. And then, no man, why do I keep on making mistakes? Sorry. Is 2 to the power of 4. And then you drop it like it's hot. And then, thus negative 2x is equal to 4. Divide with negative 2 on each side. Thus, x is negative 2. All right, let's look at the next one. Looks quite tricky. I'm going to take it slowly. So, remember, 1 to the power anything. So even if you say 1 to the power negative 4, it will still give you 1. So it's 1 over 2 to the power negative x. I'm going to give myself a hiding, sorry. Is equal to, then 128 equals shift and fact, and gives you 1 over 2 to the power of 7. Okay, so then I'm going to bring this upstairs. Bring this upstairs. Thus, it's 2 to the power x is equal to 2 to the power negative 7. Thus, x is equal to negative 7 because I dropped it like it's hot. Okay, you can always test in your calculator. So if I put 1 divided by 2 equals all raised to the power negative 7, it should give me 128. No, wait a minute. Sorry. I'll have to quickly have a look here. Sorry. So if you remember when you replace it in your calculator, if you've got a half, put in your calculator, all raised to the power negative 7, which will in fact make it a half to the power of 7. And that does give you 1 over 128. So I just want to check it again. 0.5 equals all raised to the power positive 7, then gives you 1 over 128. Okay, cool. Next one. So remember, we don't want a coefficient. So what we're going to do is we're going to divide by 3 on each side. Then we are left with a third, all raised to the power x, is equal to 243 divided by 3, which gives you 81. I'm going to make them all a product of the primes. I'm first going to get rid of this bracket. 1 to the power x stays 1 over 3 to the power of x is equal to 81 equals shift fact, which gives you 3 to the power of 4. Bring this one on the same level as the other one. So it's 3 to the power negative x is equal to 3 to the power of 4. You can drop it like it's hot. Thus, x is equal to negative 4. Okay, because if you divide with a negative on each side, the 4 will become a negative. Okay, again, you can test it. So 1 divided by 3, a third, all raised to the power negative 4 times by 3 gives you 243. Okay, and then, only a few more to go. Sorry, it's taking a long time. Okay, I'm going to try and go a little bit faster. 81 equals shift fact gives you 3 to the power of 4 is equal to 27 raised to the power 4. So 27 equals shift fact, which gives you 3 to the power 3, and it's all raised further to the power of 4. So I'm first going to simplify that. 3 to the power 4 is equal to 3 to the power 3 times 4 is 12. Again, sorry. No, okay, I'm just going to carry on. 3 to the power 3 all raised to the power of x. So I want to make sure, or is it 4? Shift fact, it's 3 to the power 4. Sorry. So the 81 I replace with 3 to the power 4, all raised to the power further x, and 27 becomes 3 to the power 3, all raised to the power 4. So yeah, it will become 3 to the power of 4x is equal to 3 to the power of 12. Now we can drop it like it's hot. Thus 4x is equal to 12. Thus x is equal to, if you divide by 4 on each side, x is equal to 3. So 81 to the power of 3, you can go test it, gives you 531,441. And if you say 27 to the power of 4, it gives you 531,441, which means that I was correct. Okay, so now we've got 5, 25, and 625. Luckily, we know that they're all prime bases of 5. So thus, I'm just going to make them all a product of their primes. 25 becomes 5 squared, all raised to the power n minus 1. And if you put 625 into your calculator, you get that it's 5 to the power of 4. Okay, then I'm going to simplify that bracket times 5 to the power 2n minus 2 is equal to 5 to the power of 4. Then you have to remember your exponent rules. If you've got the same base, you can keep your same base and you add the exponent. So what is n plus 2n? That will become 3n, and nothing else but the minus 2 is equal to 5 to the power of 4. So now we've got one base. I can drop it like it's hot. Thus, 3n minus 2 is equal to 4. Thus, 3n is equal to 6. If I take that negative 2 over, I add it on the other side. Thus, n is equal to 2 because I divided by 3 on each side. Again, you can go test it by putting the n in there, expanding and simplifying, and see whether your left hand is equal to your right hand side. Okay, last two. Sorry, and I know I've made a few mistakes as we went. Okay, so 121 equals shift fact, and that gives you that it's 11 to the power of 2. And that is raised further to the power negative y, is equal to 1 to the power 10 stays 1 over 11 to the power of 10. Okay, so I'm just going to keep it like that because then it stays my prime base as 11, which is the same that I have on this side. Then a power raised to a further power you multiply, which gives you negative 2y. And if I want to bring this up to the same level, I'm going to take it up. But what happens is my power becomes a negative now. So now I've got my prime base is the same. I drop it like it's hard. And I've got negative 2y is equal to negative 10. Divide with negative 2 on each side. And you get that y is equal to 10 divided by 2 is 5. Negative divided by negative is a positive. 10 divided by 2 is 5. You can go put it into your calculator. 121 to the power of negative 5 gives you one heck of a number. 3.855432894 times 10 to the power negative 11. And I'm just going to see if I get that the same on the other side. 1 divided by 11 all raised to the power 10 gives you exactly that same number, 3.855432894 times 10 to the power negative 11. As long as we get our left hand equal to the right hand. Okay. Over here, we're just going to use our calculator. We're going to make this fractions. So 0.5 we know is a half. That is all raised to the power a. And 0.125, if you don't know, you put in your calculator and you get 1 over 8. What is not prime numbers? The 8. And I need to simplify this bracket. Okay. 1 to the power anything stays 1 over 2 to the power of a is equal to 1 over 2 to the power of 3. Let's bring them all to the same level. Changing the exponents. So it's 2 to the power negative a is equal to 2 to the power negative 3. We drop it like it's hard. And we get that a is equal to 3. Okay, so you can write negative a is equal to negative 3. But if you divide with a negative on both sides, you get a is equal to 3. All right, grade 9s. There you go. I know that we had to really rely on our grade 8 solving equations, prior knowledge that we were taught in grade 8, but it will help you. And please, so it's just practice the negative exponent to the positive exponent, getting the bases the same, dropping the bases, equaling the exponents to each other. Okay, so I truly hope that this helped, and I hope you have a wonderful, wonderful day further. Thanks for watching. Bye.